So we're going to talk about the Pre-Calculus Edgenuity Section 7.1 called Cramer's Rule. And the objective of this section is to solve a system of equations using Cramer's Rule. Pretty straightforward. So let's consider solving this system of equations. Matrices and Cramer's rule allows us to solve systems, okay? And the way Cramer's rule works is we're going to create a new matrix A sub x and take its determinant. We're going to create a new matrix A sub y and create its or find its determinant. And we're also going to have to find the determinant of A. And this A is the same A that we found before. So another note and something that you'll need for the quizzes, or for the quiz for this section, is that you always need one more determinant than the number of equations that you have. So, for example, up here, I have 2 equations, so I'm going to need 3 determinants. The determinant of A, and then an A sub x, and an A sub y. So let's talk about how to get all that. Let's take these 2 equations here, and we'll write the matrices that would come out of that, as though we were going to solve them with inverses. So we would create matrix A, which is the coefficients, that is the numbers attached to the variables. So there's matrix A. And then remember, matrix X is just the variables in one column. We call that matrix X. And it equals matrix B, which is the constants for it. So the whole thing originally looked like that. Now we have to find these new matrices A sub x. So now we'll need a new matrix A sub x. And the way we're going to build A sub x is we're going to take B, we're going to take these numbers here, and we're going to put them in the x column. And then we're going to recopy the rest of A. So the first column of A sub x are the answers. So like that. And the second column just gets copied. So if you think about it that way, here's our x column, here's our y column. And to get A sub x, what I did was I replaced our x column with our answer column. Okay? And we're going to build A sub y the same way, with the same idea. This time I need to replace the y column. So the first column looks like that, 3, negative 2. And the second column is now the answers. So there's A sub y. So then we just have to get all of our determinants. So the determinant of A would be 3 times negative 5 minus 1 times negative 2. Remember, we go to A, and you go those diagonals minus those diagonals. Okay? And so the determinant of A is, what is that? That's negative 15. And then if you think of this as plus -1, then it's -1 times -2, which is +2, so +2. So that's -13. So A is -13, or the determinant of A is -13. The determinant of matrix A sub x is, let's see, that would be -7 times -5 minus 1 times -4. Let's change that minus into plus negative. And that would be 35, positive 35, plus positive 4, so 39. And then the matrix, or the determinant of matrix A sub y is going to be 3 times -4 minus -7 times -2. Let's change that. Minus becomes plus, the opposite. So it goes to plus positive 7 times -2. And that'll be -12 plus -14, which is -26. And so then here's what Cramer's rule says. It says that to find the value for x, that is that x right there, to find the value for x, you take the determinant of ax, which we now know is 39, over the determinant of a, which is -13, and 39 divided by -13 you'll find is -3. Oops. Circle that a little bit better. And then y is right here, the determinant of a sub y over the determinant of a. And so that is -26 over -13. Negative divided by a negative is a positive. 26 divided by 13 is 2. So x is -3, y is 2. And if you wanted to write it as a point, that is where these two lines intersect on the graph, you would write it as the point -3, 2. So there we have that. I will pause for a moment, let you look at that, and see if there are questions. Okay, there being no questions, I will move on. All right, let's do another one. So matrix A here, and I'm not going to write out all the matrices this time because the whole point of Cramer's rule is to make this quicker, okay? So matrix A is 5, 2, 2, -3, -5. Matrix A sub x then is replace these two with the answers right there. So the first column is 14, 3, and then copy the second column from A. And then matrix A sub y is copy the first column and replace the y column now with the answers. So 14, 3 right there. And then x equals, and I'm going to use different notation because Edgenuity likes to go back and forth in the notation. X equals the determinant of a sub x, which is the determinant of, that matrix right there. And remember, those bars indicate that we're taking the determinant, over the determinant of A. Whoops. That's not -2, that's +2. Over the determinant of A. So then that would be, let's see, that's, wow, a big number. 14 times -5 is -50 plus 20 is -70 minus 2 times 3, which is 6, over 5 times -5, which is -25, minus 2 times -3, which is -6, so change that to the opposite. And so we've got -76 over -19, I believe. That looks right. Which comes out to a positive and a positive what? (76 over 19), whatever that might be. And you could check that with a calculator or whatever you needed to do, right? And then y is equal to the determinant of A sub y, which is this matrix right here, over the determinant of A again, and again, I'm using this notation because Edgenuity likes to jump back and forth and sometimes use this notation. Okay? So that would be 15 minus -3 times 14, which is 30, plus 12 is 42. So change that to the opposite, plus the opposite. And then we already know the determinant of the other one is -19 from above. And so that's going to be, what, 67? No, 57. Over -19 and whatever that comes out to be. Okay? I suspect these both divide evenly. I just don't know what they are. Is the first one 6? Maybe 6 times 19 would be 60 plus 54. No. Would it be 4? 40 plus 36. Yes. So this one is 4. And this one is positive divided by a negative is negative. And this one should be 3 then. 30 plus 27, yep. So -3, giving us a solution of 4, -3 as the point of intersection. I'll pause for a moment to see if there are questions. Let you get a look at it. All right, there being no questions, I will go on to the next one. All right, so now let's use Cramer's rule with 3 of them. So now we've got a 3-equation system, meaning we're going to need 4 matrices and 4 determinants to use Cramer's rule. So we'll still need A, And A still looks the same. It's just the coefficients, the numbers attached to each variable. So that would be 1, 2, negative 1, 1, 2, 1, and 1, negative 1, 2. By the way, I noticed in the lesson that Edgenuity has that one is actually written as 2x, but they mean for it to be 2y. So just a little note there. Then you still need an a sub x, where you replace the x column with the answers. And then copy the other columns. And you need an a sub y, where you copy the x column from A, you replace the y column with the answers, and you copy the z column as is. And then you need an a sub z, where you copy the x and y columns, and you replace the z column with the answers. So then x is the determinant of a sub x over the determinant of a. Y is the determinant of a sub y over the determinant of a. And z is the determinant of a sub z over the determinant of a. And I'm going to use technology to do this, and the technology that I'm going to use is meta. Let me do that in a different color, actually. I'm going to use meta-calculator.com. This is a browser-based calculator, and one of its options is a matrix calculator. So you want to go to meta-calculator.com and choose the matrix calculator. And we'll put in matrix A as we see it there. So 1, 2, negative 1, 1, 2, 1, and 1, negative 1, 2. And then we'll use B as each of the things, and we'll get determinants, okay? So the first matrix B will be our A sub x matrix. So negative 4, 2, negative 1, negative 1, 2, 1, and 3, negative 1, 2. All right, and what I can do is I can get the determinant of B, which is the determinant of A sub x, and I'll write that down here. That's negative 5. And I can get the determinant of matrix A, which is 6. So now immediately I know the answer to the x value. It is negative 5/6. And then I have to change to matrix A sub y. So I'm going to change matrix B. I'll keep matrix A as it is, and just change matrix B to be A sub y. So that'll be 1, negative 4, negative 1, 1, negative 1, 1, 1, 3, 2, and I'll find the determinant of matrix A sub y again, and that will be negative 5. Just so happens that it's the same answer. That's just a coincidence. And the determinant of matrix A I already have, so 6. And then I'll do the same thing for matrix Z, or for matrix A sub Z, sorry. So that would be 1, 2, negative 4, 1, 2, negative 1, and 1, negative 1, 3. So now I have a new matrix B. I'll get the determinant of that, and that is the determinant of my matrix A sub Z, which is 9 and 6. So what I have now is the determinant for each one, and I have answers here. Negative 5/6 for x, negative 5/6 for y. I can't reduce those or anything, so I'll just leave them like that. And 9/6 for z, which I could reduce by 3 and call 3/2. So there is all three of my answers, and I could put them in a three-dimensional plane, in a three-dimensional coordinate system answer, which would be negative 5/6 for x, negative 5/6 for y, and 3/2 for z. And that would be where those three lines intersect on a three-dimensional coordinate plane. I'll pause for a moment to allow for questions. Okay, there being no questions, I will move on. One more of these. Let's do this again, just to get to practice here. So matrix A would be 3, 4, negative 1, 5, 8, 2, negative 1, 1, 1. Matrix A sub x would be replace the x column with the answers. So the first column would be negative 6 to 0, 2, 0, and then copy the other columns, 4, 8, 1, negative 1, 2, 1. Matrix A sub y, replace the y column and copy the other columns. So 3, 5, negative 1, negative 6, 2, 0, and negative 1, 2, 1. And matrix A sub z is copy the first two columns, 3, 5, negative 1, 4, 8, 1, and replace the z column with the answers. So negative 6 to 0. And then x is the determinant of A sub x. over the determinant of A. Y is the determinant of A sub y over the determinant of A. And Z is the determinant of A sub Z over the determinant of A. And I am going to just put them into the three-dimensional coordinates once I have calculated them, but I need to plug in my A and so forth, so let me do that. So we've got, I'm in MetaCalculator again to do that. We've got 3, 4, -1, 5, 8, 2, -1, 1, 1. And then my first matrix B will be the A sub x matrix, so -6, 4, -1, 2, 8, 2, 0, 1, 1. And I'll get, that is, this one's -46 for A sub x. And the determinant of A is -23, so -46 divided by -23 is +2. And then I'll put in A sub y for my matrix B now. So that will be 3, -6, -1, 5, 2, 2, -1, 0, 1. And let's see, that's +46 over -23, so that's -2. And finally, let's put in A sub z for matrix B. That's 3, -6, -1. Oh, whoops, no, sorry. 3, 4, -6. I was looking at my A sub y again. 5, 8, 2, -1, 1, 0. And that is -92 over -23 again. Which is 4, +4. So the z-coordinate would be 4, and so there would be my x, y, and z right there. I'll pause for questions. Okay, there being no questions, I will move on. This comes from things that were in either the practice problems or in the quiz that had slightly different notation, and I thought you should at least see sort of what it looks like so that you're prepared. What is the determinant of A sub x for this? Well, here's A, right? So A sub x would be replace the x column, which is that column right there. So replace this column with the answer column. So 7, -51, and then keep the other columns. So -13, -22. So then the determinant of A sub x is 7 times -22 minus -13 times 51. So 7 times negative 22 is a negative, and then it's 140 plus 14 is 154, I believe. This becomes minus becomes plus the opposite. So 13, so that's a negative. 13 times negative 51 is a negative. And then maybe I'll do some side work here for 13 times 51. That's 3, 1, put a 0, 15, carry the 1. 5 times 1 is 5, plus 1 is 6. So 663. So then add 663 and 154 gives us 7 and 11, carry the 1. 7, 8, 817, and it's negative. So negative 817. That would be an ugly one to try and do the whole thing with, but this isn't going to ask you to do the whole thing in these problems. It's just going to ask you to find one specific determinant. Okay? And last thing, well, I'll pause to make sure there aren't any questions. Okay, there being no questions, one last note. If you do all the determinants for Cramer's rule, the A sub x, the A sub y, and so on, and they all come out to 0, then there are infinitely many solutions to the system. On the other hand, if the determinant of matrix A comes out to 0, but not all of the other ones do, then there are no solutions. The idea is that this matrix A coming out to 0 means you're dividing by 0, which is an undefined answer and doesn't tell you a lot. It tells you that there isn't a unique set of answers. They're either infinitely many or none, and the way you can tell the difference is if all of them are 0, it's infinitely many. If not all of the other ones are 0, then there's no solution at all. Okay? So I hope this has helped for section 1.7. Thank you so much for listening.